Hello everyone. We are going to be starting with statistical inference using significance test about hypotheses. In here, we're going to look at significance test. What do you mean by that? And some basic concepts relating to hypothesis testing. So the first thing is, what is significance test? Before I go deeper into it, I'm going to just talk about things we have done earlier. Remember, we have used point estimates or interval estimates to make some statistical inferences about the population using sample data. Our main focus in that scenario was to use confidence intervals to make analysis about the population characteristic. And this population characteristic was either proportion or a mean. Now here we're going to use a second type of statistical inference, which is called the significance test, or test for short. Now here we are going to be using, so what basically do we do in significance test? We say, we make a claim and we say, depending upon these scenarios, I think this is going to be true or this may not be true. We make some claims or hypotheses about a population. And now the thing is, okay, we have made a claim, we'd like to support it. So what we do is we take a sample data and we decide whether the claim we are making about a population is plausible. And this is where a significance test helps us to summarize the evidence about this hypothesis. One of the biggest assumptions is we are assuming that the sample data we are using is randomly generated, and it uses the probability to provide a way to quantify how possible a parameter how possible it is there while controlling the chance of an incorrect answer. Now, before we start applying it to some hypothesis, we need to have some basic concepts under our belt. So, as I said, we're going to look at some basic concepts. Let's start with them. So the first basic concept we're going to look at is hypothesis. What do you mean by hypothesis? Hypothesis is a statement about a population, usually of the form that a certain parameter will take on a certain numerical value, or it will fall within a certain range of values. So basically, we're making a claim and saying, hey, this will happen, and it is a numerical value. And we are only relating it to a parameter. Remember, when we say the word parameter, parameter is related to the population. Now, this is an assumption we are making. Now, this assumption may or may not be true. So let's look at some of the examples of this hypothesis. For example, the average annual compensation for used car salespeople is $46,000. Somebody might say, I don't believe. They say, the average annual compensation for used car salespeople is more than $46,000. Okay. Now let's talk about some food here. It says the mean weight of all bags of pretzels differs from the advertised weight of 454 grams. So these are some of the claims. Now let's look at what a hypothesis statement looks like. Now, when we make a hypothesis statement, every significance test we are going to make will have two hypotheses. The first is the null hypothesis. Null hypothesis is always assumed to be true, that this is the status quo. It is an established belief. Okay. Now, the alternative hypothesis, which we denote by HA, H sub A or HA, it's a new idea. It challenges the status quo. It states that the parameter falls in some alternative range of values. Okay, this is all words. Let me see some equations. So here is a proper form of a null and alternative hypothesis. Remember, the null hypothesis means it is the status quo. It is assumed to be true. So when I write the null hypothesis, H sub 0, it's a parameter equals hypothesized value. Remember, hypothesis means you will have a population parameter equal to something. Okay? It's a numerical value. So the biggest catch is, how do you know it's a null hypothesis? If you see an equal sign. And you should have a parameter on one side of the equal sign, and on the other side, you will have a numerical value. Okay, what would be the scenario for an alternative hypothesis then? The alternative hypothesis has three different possibilities. First of all, either the parameter is strictly greater than the hypothesized value, or the parameter is less than the hypothesized value, or the parameter is not equal to the hypothesized value. Okay, so when we have an alternative hypothesis where the parameter is greater than, and it has to be strictly, there's no equal sign. The biggest giveaway for an alternative hypothesis is there is no equal sign. Either it is a strict greater than, a strict less than, or not equal to sign. Now, if you have a strictly greater than symbol, and if it is this scenario, parameter strictly greater than hypothesized value, it means we are looking at a one-sided test or a right-tailed test or an upper test, whatever you want to call. Now, if my alternative hypothesis is a parameter strictly less than the hypothesized value, it means I'm having a one-sided test or a left-tailed test. If the third scenario where we have a parameter is not equal to the hypothesized value, that means we're looking at a two-sided test. This, guys, this whole slide is a very, very important slide. Please keep this in mind. Now, let's do some examples. We have talked about a little theory. Examples. Now, for each of the statement given below, deduct whether it is a null hypothesis or an alternative hypothesis. So null means H sub 0. An alternative hypothesis means H sub A. So let's read the first one. In Canada, the proportion of adults who favor legalized gambling equals 0.5. You see the word equal? That means simply it's a null hypothesis. Okay, the next one. The proportion of all Canadian students who are regular smokers is less than 0.24, the value it was 10 years ago. The catch is less than. That means it's the alternative hypothesis. The next example, the mean IQ of all students at Lake Wubicon High School is larger than. See the word larger? That means it's an alternative hypothesis. Then the example, the probability of rolling a 6 with a particular die equals 1/6. Equal means I am dealing with null hypothesis. The last problem, the proportion of all new business enterprises that remain in business for at least 5 years is less than 0.5. Once again, a less than is a giveaway for alternative hypothesis. Okay, so this was just familiarizing ourselves with null and alternative hypothesis. Now let's look at another example. Here we will write now. It says mean area of apartments in a new development is advertised to be 1250 square feet. Now, a tenant group thinks the apartments are smaller than what they are advertised. So they hire an engineer to measure a sample of apartments to test their suspicion. What would be the null and the alternative hypothesis? So the first thing to keep in mind is when we are writing down hypotheses, we need to know what is the parameter we are working with. That's the most important thing, the parameter. So if I look at let's read back the problem again. Mean area of apartments in new development is advertised to be 1250 square feet. The catch is mean. That means my parameter is mu. Mu and mu. That's the first thing. Second, null hypothesis will always have an equal sign. Okay, the alternative is we'll read the problem again and we'll know less than, greater than, not equal to. Okay, let's read it. The problem again. It says mean area of apartments in a new development is advertised to be 1250 square feet. That means this is what they're saying. The mean area, so this mu is representing a mean area. It's 1250. Okay. Now let's read the next sentence. A tenant group thinks that the apartments are smaller than what is advertised. That's the giveaway. The smaller than means the alternative hypothesis is strictly less than 1250. And we're done. Okay, let's go and do another problem. For each of the statements given below, state the hypothesis in terms of the parameter values. Okay. Here, the first says, in Canada, the proportion of adults who favor legalized gambling equals. Now remember, we just did this example a few minutes ago, and we're looking at equals means it's a null hypothesis. So I have definitely null hypothesis means H sub 0. What's the parameter? Proportion. The proportion of parameter is represented by the symbol P. Equals 0.5. So we are stating the hypothesis in terms of the parameter. So this is what the problem is. Okay. Now, let's look at the next one. It says the proportion of all Canadian students who are regular smokers is less than. That means this problem is giving us the alternative hypothesis, H sub A. And it is again proportion, P. And the less than means strictly less than symbol, 0.24. That's what the question was. Okay, let's look at some more examples. Suppose the mean GPA of all APSC students graduating in 2000 was 3.05. The registrar plans to look at records of students graduating in 2016 to see if the mean GPA has changed. State the null and alternative hypothesis for this investigation. So guys, here's the scenario. Whenever you're reading a problem, as you read, underline the main things. Now remember, these are problems related to hypothesis. That means you need to know what is the parameter. And once you know the parameter, you can figure out whether what kind of information is given. Is it the alternative or the null? So as you read, make sure you underline those specific words which are the triggers for us. So here, once again, we're going to read it. Suppose the mean GPA. Here's the first important part. The mean, that means that's my parameter, of all APSC graduating students in 2000 was 3.05. Okay, this is the hypothesized value and this is the parameter. Okay, now the registrar is looking at records of students who are going to graduate in 2016, 6 years later, to see if this mean GPA has changed. That is a giveaway for our alternative hypothesis. And now we simply can write down. So we say H sub naught or H0 is the mean, that's mu, equals 3.05. Okay. Then H, the alternative hypothesis, HA, is mean has changed. That means either it can go up or can go down. The symbol is not equal to 3.05. Okay, let's look at a different kind of questions which can be asked to us. For the following pairs, indicate which do not comply with the rules for setting up hypotheses and explain what is the problem there. So the first one, H sub 0 is mean, that's the parameter, equals 1, 2, 3. This is perfectly fine because we have a parameter and an equal sign with H0. Then H sub A, the alternative, the mean is strictly greater than 1, 2, 3. This one complies beautifully. So we have no issues here. Everything is fine. Let's look at the next one. This next one says H0, mean equals 15. Oh, that's good. Then HA, mean also equals 15. That is not possible because remember, the alternative hypothesis can never have an equal sign. So this is not possible. And the reason is the alternative hypothesis cannot have an equal sign. H sub A cannot have equal sign. Okay. Let's look at the next one. H0, B hat is 0.1. And I forgot this should be H sub A, guys. B hat not equal to 0.1. Now, it's the equals and the not equals are working, but there's the biggest problem is this B hat is a sample proportion. So this also is not right because B hat is a sample proportion. That's the notation for sample proportion, guys. Hence, this null and the alternative hypothesis is not correct. Okay. Now let's look at now we have got a little bit comfortable with reading the problem, writing the null and the alternative hypothesis. Okay. Now when we have these hypotheses, we like to make analysis. What does it give us? That's the main part for us. So in significance testing, we use sample data to decide between the two competing claims. That is the hypothesis about a parameter and that is the population characteristic. So when we test a null hypothesis versus the alternative hypothesis, the hypothesis, null hypothesis, that means that is an established claim. This is assumed to be true. Now this is going to be rejected in favor of the alternative if the evidence we get from the sample is suggesting very, very strongly that the null hypothesis is false. Only then the rejection would be there. But if the sample does not give us such evidence, we say, nah, it's not going to work. We are not going to reject or fail to reject the null hypothesis. So there are only two possible conclusions. One, rejection of the null hypothesis or failure to reject the null hypothesis. Okay guys, let's apply to one more example and using the null and the alternative and the analysis here. Now I've written down the answers for you, but I will go through with you here. Okay, so the problem is a medical research team has been given the task of evaluating a new laser treatment for certain type of scenarios. The current standard treatment is considered to be reasonable in safety by the medical community. It has no major side effects, has a known success rate of 0.85 or 85%. So what's happening is this laser thing, which is currently in vogue, is working beautifully and everybody's happy with it, has a success rate of 85%. But, as things keep on progressing, new technology comes in and a new kind of laser treatment has popped up. So the question is, we'd like to test whether it is a better one than the one which is already working. So here, how do you know what kind of parameter it is? The moment, guys, you see something with a percentage, that's a giveaway, it's a proportion. That's how you look at it. Okay, now the null and the alternative. Remember, the null would be b equals 0.85. What would be the alternative? Now remember, when I read this problem, why would I go and buy some expensive laser treatment unless it is better than the previous, the one which we are working with? So the alternative hypothesis is, in order for the alternative hypothesis to really come out, is that the proportion should be strictly greater than 85%. Because remember, in order to have a new kind of a treatment, there's a lot of expenses and a lot of, the new way of learning, a lot of things have to work. So for these kind of things to work, and I'm just trying to give you a very logical reason why the alternative hypothesis has to be strictly greater than. Because if we say, oh, it's less than, then why would I spend a couple $1,000s to get a new laser treatment when the old one is working perfectly? So, you've got to be very careful of writing down the alternative hypothesis. And specifically, what you need to do is read the problem. Take your time, read it, and then go ahead and say, oh, this exactly fits the problem. Okay, now let's look at the analysis. We're going to discuss the analysis of rejecting the null hypothesis in response to the above scenario. So rejection of the null hypothesis is an indicative of compelling evidence that the success rate of the alternative is very higher for this new laser treatment. That means the success rate is very, very high. Only then you're going to, get rid of the status quo of the null hypothesis. Okay, suppose if the null hypothesis is not rejected, what is the analysis? If the null hypothesis is not rejected, or we fail to reject, then we are able to conclude that there is not sufficient evidence that the new treatment has higher success rate. Thank you, guys.